Hi everyone, this is Li. Today I'm going to show you my master thesis project, a RFID system used for the wireless body area network. First, let me introduce the background, the system architecture, and the general operation of this RFID system. This diagram is a body area network. For a body area network, it includes sensor nodes, wearable unit, and station unit. The sensor nodes collect the information of our body. Wearable unit collects all the information from the sensor nodes. The data collected by the wearable unit can be transmitted to the station unit. The station unit can connect it to the doctors through network to fulfill the remote diagnosis and healthcare. In this system use case diagram, you can see the human here is a specimen. The implantable unit is going to implant it inside the body. The wearable unit is used to wear on the body to collect the data from the implantable unit. The operator is control the operation of the system through the control user interface. This is the system architecture of this project. In this RFID system, it includes an implantable unit, a wearable unit, a Raspberry Pi, and a control UI in the station unit. The implantable unit is a RFID transponder, which is supposed to implant it inside the human body. The wearable unit is a RFID reader used to collect the data from transponders through inductive coupling channel. The Raspberry Pi is a card-size full functional computer. It is attached on the wearable unit to control the operation of the wearable unit through GPIO port. It can connect it to the station unit through wireless network. The control user interface on the station unit can control the operation of the whole system. So this is the physical test bench setup of the RFID system. The right corner is the RFID reader, on it is the transponder coil, and up is the circuit of the transponder, the rectifier circuit, and the filter. And the left side in the middle is the FPGA evaluation board used for the Manchester code encoding and decoding. And under the FPGA board is the Raspberry Pi, so it uses GPIO port to control the operation of the FPGA. And the upper part is the logic analyzer used to sampling the signal from the Manchester encoding and decoding. So the overall system has two general working modes. One is working in the BIT mode. So for the BIT mode, it connects the output from the Manchester encoder directly to the input of the Manchester decoder. And another mode is the running mode. So this is the external input. So in this case, the output from the Manchester encoder will put to the load modulation and control the transponder to send the data through the inductive coupling channel to the reader. And on the reader side, it will have a front end to digitize the received signal and send the signal back to the Manchester decoder and finally get the decoder output. This is the format of the data in this system. The data is packed in 660 bits free, start with a 10-bit start bit. In the red area, the small parts is the data information to be transmitted, and the rest time is used for the power transmission. Compared to the traditional Manchester coding, which is 50% duty, this modified small parts Manchester coding mechanism can improve greatly the efficiency of power transmission. This is a configuration of the BIT mode. Both the Manchester encoder and the decoder are implemented on the FPGA board. Here, I separate the interface of the encoder and the decoder into two separate GPIO sockets. In the BIT mode, the output of the encoder is connected directly to the input of the decoder. And for the Running mode. The output of the encode is connected to the load modulation input on the RFID transponder. The data then is transmitted to the RFID reader through the inductive coupling channel. The information coupled on the reader can be digitized by the front end on the RFID reader. The output of the RFID reader is a feedback to the Manchester decoder. This is the signal captured by the digital analyzer. The first line is the clock signal. The second line is the indicator of the start of the bit stream. The third line is the original bit stream on the transponder. The fourth line is the bit stream encoded by the Manchester encoder. The rest 4 signals are the outputs on the reader. First one is the input bit stream. The next is the generated clock on the for the Manchester decoding. Next one is the indicator of the input bit stream. Every time when the decoder detects the start bit of the bit frame, it will generate a small pulse, then the decoder will start to work. The last line is the decoder signal, which is the recovery of the input bit stream on the transponder. Here you can see the input bit stream on the transponder and the decoder bit stream on the reader side. Now let me show you the system operation on the hardware. This is the RFID reader. This is the transponder coil, and this part is the transponder coil circuit. It has a rectifier and the bandpass filter. And this is the FPGA evaluation board used for the Manchester encoding and decoding. And this part is the Raspberry Pi. So the Raspberry Pi itself is a card-sized computer at the back, and it controls the FPGA board through the GPIO port. And I implemented Apache server on the Raspberry Pi, so I can control the Raspberry Pi through the website. On the control interface, we have 3 buttons. One button controls the system working in the BIT mode, and the next button controls the system working in the running mode, and another button to power off the whole system. I also attached a camera on the Raspberry Pi, so in this case I can monitor the operation of the system during the runtime. There are 3 red LED to indicate the operating of the Manchester coding. The first 2 are for the Manchester coding reset and enable, and the third one is used for indicating the working mode in the BIT mode or running mode. When it's on, it's working in the BIT mode. When it's off, it's working in the running mode. Another 2 green LED to indicate the working of the Manchester encoder and the decoder. So the first LED is to indicate the working of the Manchester encoder, and the second green LED is to indicate the working of the Manchester decoder. We can monitor the working of the system during the runtime through this video stream from the camera on the Raspberry Pi. So first, let's start with working in the BIT mode. So you can see all this LED turns on, and these 2 green LED indicate the Manchester coding and the decoding start working. And we can also see the bit stream from the logic analyzer, which is connected to the output from the Manchester encoder and the Manchester decoder. So let's open the interface of this logic analyzer and start sampling. So you can see this is the same signal you see from the system explanation. Now let's working in the running mode. So I'm going to click to the running mode, so you can see this LED indicate the system working in the running mode. Now the system is working in the running mode, so it takes the external input for the Manchester decoder. Now you can see this green LED start blinking. This is the indicator for the Manchester decoder. It is blinking because now it is controlled by the RFID transponder, so it takes the external input to the RFID transponder. So you can see If I put it close to the this transponder, close to the reader, you can see the green LED starts blinking. So if I just move it away, it stopped. Close, it start working, and move it away, it stopped. So this is the how this RFID system works. Okay, I'm really appreciate your time for watching this video. Thank you very much.